Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at section 7.1. This is an introduction to interest, and it's going to show us how to compute both simple interest and compound interest. So what is the difference between these two? Well, I kind of tell you, simple interest is really just computing interest that only takes a look at how much interest has occurred when it's over or at the end of the year. So it's kind of on an annual base. Whereas compound interest, it can calculate interest at any number of time intervals. It can calculate interest every week, it can calculate interest every month, it can calculate interest every day, and it can calculate interest continuously, as we're going to see. So compound interest just means that it's checking for interest at usually much smaller time periods. So instead of every year, it would be like every 6 months or every month or something like that. So here's the formula for compounding simple interest here. All you do is you're going to take your P, which is the principal. So this is the amount that either you deposit into a bank or that you are taking a loan out with. Principal is the total amount, not including any of the interest. So it's just the principal. The R is the annual interest rate, and we will put that into decimal form, not into the percentage form. And then T is the time in years. So if it's 2 years, T would be equal to 2. If it was a year and a half, T would be equal to 1.5. So you have to convert your time to years in order to use this formula. So let's go ahead and just take a look at an example here. Let's say we put $500 in the bank. So we put $500 in our bank, and we're getting an interest rate of 3.5%. So that's our interest rate, and we're leaving it in there for 10 years. And we want to figure out how much interest is it going to earn in 10 years. Sorry, my years are messed up there. How much interest are we going to earn in 10 years? So see if you can take a guess at first. See what you think it would be. Now remember, we're not seeing how much we have in total yet. That's the next formula here. All we're doing is seeing how much interest we're going to earn in 10 years. So going to our calculator, and let me pull up the calculator here. We're just going to put, so the interest is the principal, which is 500, times the rate as a decimal. So we got to convert this to a decimal. That means you move the decimal place 2 to the left, so you're going to have a 0.035, and times the number of years, which is 10. And that means in 10 years we're going to get $175 just in interest. Now if you say, well, how much are we going to have in total? Well, you just add those together. You put the amount that you deposited and the interest that you made, and you're going to get $500 or $675 total, because if we add that 500 there, that's what we're going to get. Now we have a formula that really does both of those steps in one. The A is the future value, so it'll be both the deposit or the principal that you put in, as well as any interest that you earned. So let's put that one in our calculator for this, and we should get the same value there. So this is equal to P, which is 500. Let me make my calculator a little bit smaller here so I can fit them both in there. All right, so P, which is 500, and then open parentheses, and we have a 1, plus R, which is 0.035, times our T, which is 10 years. So if we did it correctly, we should also get $675, which we do. So all this formula here is finding your interest and then adding it to your principal. All right, now let's really take a look at the compound interest formula. This is the first kind of really complex formula that a lot of people see, and it is so important because it is used all the time when we buy a car, when we buy a house, when we take out a loan. Compound interest is very, very common. And all it is, just like I said before, is instead of calculating that interest every year, it's calculating the interest every week or every day, and we're going to see what variable that is. So let's use this same set of numbers here. And remember, before we had $675. But instead of just doing it annually, let's say our compounding period, so I'll just put a CP here, CP, our compounding period, we want to compound this thing every week. So every week we want to check it, calculate what the interest should be, and add it on. And since we're doing it more than once a year, we should have more money than we do if we just do it once a year, because every week means that, well, the first week would just be normal. You just calculate the interest for a week's worth of interest. But then the second week, not only are you calculating the second week of interest on the principal, but you're also counting that second week's worth of interest on your first week's interest that you got, because you've already put that into your principal. So as you can see, it's going to build up faster. Now, the thing is it doesn't build up all that much faster. So you think, oh my gosh, we're doing it every week. We're going to have a ton more than $675 at the end, but we're going to find that it's not going to be that much more. And then we'll take a look at different time periods and see how those are affected as well. So we're using the same formula here, and this time we're going to do every week. Now, we have to convert that to how many weeks are in a year. So this is going to be equal to, we're going to put a 52 in for M. You see M down here? M is the number of compounding periods per year. So if it's done every week, that means there's 52 compounding periods per year. If it's done every month, there'd be 12 compounding periods per year. If it's done every day, you're looking at 365 compounding periods per year. And then the N is going to be the total number of compounding periods. That's the little N right here, and we're going to figure that out by multiplying our M times our T. So let's go ahead and figure out what all of these are and put them in here. So just go to my calculator, and so the future value, that's going to be the principal that I put in plus my interest. And remember, we already know that it should be a little bit more than 675 because it's calculating more interest than the previous one. So we're going to do the 500, open parentheses, 1 plus my rate, which we already said was 0.035, divided by the number of compounding periods per year. So that is, in our case, 52. Close parentheses, and then we're going to raise it to, using a little caret here, and remember the total number of compounding periods is our M here, which is the number of compounding periods per year, times the number of years we had. So for example, if it was 2 years, we would have a total of 104 compounding periods. But this is 10 years, so we should have 520 compounding periods because it's 52 every year for 10 years. But I'm not going to do that. I'm just going to put 52 times 10. So it's my M times my T times the T, which is 10. All right, so let's see what our total value is when we put all of this in here. Oops, I think I put it in extra. It should be 52 times 10. 52 times 10. All right. I did the 520 a little bit early. Hit enter. And we see that we got about 25, 35, almost $40 more by compounding it every week. So instead of getting $675 at the end of 10 years, we're actually getting $709. So an extra about 35, almost 40 bucks. All right, now let's see how much we'd get if we did it daily. So you're going to put in the same numbers here, 500, open parentheses, 1 plus the interest rate, which is 0.035, divided by M, which is the number of compounding periods per year. So if you did it daily, that would be 365 days in a year. And then we're going to raise that to the 365 times, because it's 365 times a year per 10 years, so we're going to multiply that by 10, and we are going to get 709.52. So look at that. We only made 7 more cents by changing it from weekly to daily. So it's not that huge of a difference. All right, let's take a look at another example here. All right, so give this one a try and see how you do. So we're depositing $850 for 3.5 years, an interest rate of 5.22%, compounded quarterly. So go ahead and give it a try, and when you're ready, unpause, and we'll go through the solution. All right, so what I like to do here is I like to solve for my variables. So my P, that's my principal. That's going to be the $850. And then I need to know what my R is. That's my interest in decimal form. So I'm going to have to move the decimal place 2 to the left. That's going to give me 0.0522. And then I need to know my M. That's the number of compounding periods per year. Quarterly is every 3 months. So that's 4 times per year. So M is equal to 4. And then finally, my N is equal to, remember, that's M times T, right? That's the number of compounding periods per year times the number of years. So in this case, it's going to be 4 times, and 3.5 is 3.5. So 4 times 3.5, 4 times 3.5 gives us 14. So that's going to be our N, 14. And then it's just a matter of really plugging it all in here. So we're going to get 850, open parentheses, 1 plus the R, which is 0.0522, divided by our N, which is, or M, which is 4, raised to the 14th power. And it looks like after 3.5 years at this interest rate and compounding quarterly, we're going to have about $1,019.18. All right, let's move on to the next part here. Okay, so this one's going to be a little bit trickier, and we have to know an exponent property of the log function, which is on page 384 in the book. So just follow me along. You might see 1 or 2 of these in your homework. Don't freak out. But it says Dee Dee has invested $8,500 in old Star Wars memorabilia, which is currently increasing in value at a rate of 6.5% per year. If this increase continues at the same rate, in how many years will Dee Dee's investment double? All right, so if you want to go ahead and give this a try, go ahead. And then when you're ready, unpause and we'll go through the solution. All right, so we are going to be using one of these formulas here. And the question is, which one should we use? And we go ahead and use the compounding formula. So let's go ahead and solve for our variables. Now, A is the future value. Now, the future value is when this thing doubles. So what's double of 8,500? Well, that's just 8,500 times 2. So we're trying to see how much time it's going to take for it to double, which is get up to 17,000. So that's going to be our A in this case. Our P is going to be our principal. That's our initial investment here. So that's going to be 8,500. And then we're going to have our R, which is our interest rate in decimal form, so 0.065. And our T, that's the how many number of years will it take to double. Well, that's our unknown here. That is our unknown. And our M, Our M is, let me see, it says per year, so that's annual. So that would be 1. So with all this information here, I'm going to put it into the formula. Try to give myself some more room for this one, and it's going to look like this. So A, which is 17,000, is equal to P, which is 8,500, times 1 plus our R, which is 0.065, all over M, which is 1, raised to the M times T. So that's 1 times T, right? Which is just going to end up being T. So simplifying this, I'm going to go ahead and divide both sides by 8,500. So if you divide both sides by 8,500, you're going to get a 2 over here, because that's 1,700 divided by 8,500 is 2, is equal to 8,500 divided by 8,500 is 1. And we're going to get 1.065, because that's 1 plus 0.065 divided by 1, because, well, 0.065 divided by 1 is 0.065, plus 1 is 1.065 raised to the t. So this is our formula here. Now, whenever we're solving for a variable in the exponent position, and I know this is probably something most of you haven't seen, this is the step that we're going to take. We're going to take the natural log of both sides, so you just put a little ln, and that stands for natural log. So natural log of 2 is equal to natural log of 1.065 t. Oh, raised to the t. And the special property of logarithms, which is on the bottom of page 384, says that if we have a logarithm, we can take the exponent here and put it out front. So this is going to be equal to natural log of 2 is equal to t times the natural log of 1.065. And the last thing that you're going to do to get that t by itself is divide both sides here by the natural log of 1.065, which is just a number. And you have to do it on this side, natural log of 1.065. So those will cancel out, and we'll just have t is equal to this. And this is something that we can put into our calculators. So depending on what calculator you have, you should have a little button here that says ln. So this is going to be the natural log of 2, the natural log of 2 divided by the natural log of 1.065. The natural log of 1.065. And we're going to get about 11 years. So this is about 11 years that it's going to take for this investment to double. All right, so this is how you do it. The trickiest part is when you get to here, and then you got to take the natural log of both sides, bring the variable out front, and then do a divide. All right, guys, that's all I have for you today. If you have any questions, please let me know or put them in the forums, and I hope you all have a great rest of your week. Thanks.